Hello everyone, how are you? I was getting few questions and queries from some of my colleagues and my contacts. How do I report OPD waiting time? Usually, the OPD waiting time is reported in averages in hospitals, and calculating averages is not an issue, which is very easy. You have all the data points, and all of us can calculate averages. Now, the problem with averages is that when you have, say, OPD waiting time data points, and let's say you have a waiting time data point like 10 minutes, 15 minutes, 11 minutes, and all of a sudden you have a data point which is 60 minutes. So now it sort of distort the whole average thing, and it shoots up your average now, which is not a true picture. If you have one data point 5 and you have another data point 45, the average comes out to be 25, and neither of them, 5 and 25, 45, is being reflected by the average data point. Now to tackle this issue, what we need to do is we need to find a way of how do we um, separate the outliers from the data points, and how do we calculate an average which is excluding the outliers. Now I do it very often when I report the waiting time in OPD settings in our hospital, and I'm going to teach you how do you calculate the averages without getting impacted by the outliers. The formula is very easy, and I usually do it in Excel, and the same formula is being implemented in the systems whatever you're using. If it is EMR or some other Power BI tool, a business reporting tool, you can implement the same formula. So let's do one thing. I'm going to take 100 data points for 3 months each, and then we'll calculate the averages, and then we'll also see how do we take out the outliers. So let's say I have 100 data points. I'm creating this data set: 100 for, say, Jan, 100 for Feb, and 100 for March. Let me do one thing: Jan, and I'll just assign this a label so that then we can create a pivot table around it. So this is Jan, all my 100 data points. Now this is my Feb, this is my, I think what I did was I label the second 100 as well as Jan. I'll do it Feb, and these 100 data points are my Feb data points. Then I have March, next 100 data points. So this is March. All right. So let's assign a random waiting time data to all of these labels, and let's say it is random between 10 minutes to, say, 40 minutes, which is okay. And we'll drag down to all, and then we'll just copy these values and paste it as values. Otherwise, with this random between, these numbers will keep on changing every time we do in the we update the sheet, or we do anything in the sheet. So I can delete this now, it's of no use. All right, so let's say we have these data points for Jan, Feb, March. Usually you would have these data points in thousands. Each patient represent a one data point, which is one waiting time. For the testing purpose, I'm just taking 100 data points for Jan month, 100 for Feb, and 100 for March. I'll just create, assign this as a table, and I'll create a pivot table based on this. Here is my pivot table. All right. So if you see, I'll just drag month in rows and waiting time in sum of waiting. It is showing sum of waiting time by default. So we need to change this to averages. So here is the average right now. Let me also create. Okay, we'll do this later on. Okay. So here is the average of waiting time Jan, Feb, March. Now usually what happen, let's say you have in Jan one of the data point which is not 21, which is say 85. And this way we'll introduce, I'll just highlight this, some outliers in our data set. So let's say this is 100 for some reason, because the system did not capture the right value, or anything can happen. Usually the system is very unpredictable. You might have something that might have gone wrong in the system, and you would always have these kind of values. So I'm just putting these values. Let's say on this particular day, back to back something happened, and by default the system captured 100 and all that. Or maybe on one day there was when the patient arrived and when the patient left, so somebody forgot to mark the patient as departed, and eventually what happened was that this waiting time went on for more than 4 hours. So I have added these outliers in my data set. Let's do the same thing for Feb month as well. Feb month, I will add 150. For some reason, something went wrong. This patient waited for 300 minutes because somebody forgot to mark this patient as departed. This something went wrong. Something went wrong. And let's say, let's put something here which is 185. Something went wrong. Okay, so we have included outliers in my Fab dataset. Same I will do in March dataset. And these data points could be genuine, but these data points could be because of some system calculation error, which keeps on happening all the time. And with thousands of data points, it would be very difficult for you to pick up these outliers. And eventually what would happen is that your averages which is being calculated would be wrong. So I'm just introducing these outliers in my data set. Let's say, all right, all right, let's go. So you see that before this average, before the outlier was this one. I'll just copy paste this value here. And now I'll refresh this pivot. You will see now the average has gone 32, 32, 35. Now of course this is not correct. The reason is that because this average is going up because of these outliers data points, which is sort of distorting my calculation and is putting giving me a wrong estimate. And I need to take care of these data points so that when I calculate my averages, these outliers are not counted into it. So what do I do? So we have a statistical way of calculating the outliers. So what you do is you calculate the first quartile, which is your 25% of the data set is below this range. So it is, so there's a formula, and I'm picking the first quartile, which is 25th quartile. I'll put 1, and this will give me 18. So my 25% of the data points are below 18. I'll calculate the quartile 3, which is, I'll select all the data points and I'll select third, 75th percentile. So all my 75% of the data points are below this 35 number. Then what you do is you use calculate q3 minus q1, which is a difference between these two numbers, this minus this. and then you multiply this difference by 1.5, q3 minus q1. So you multiply this number difference by 1.5, so it gives you this number, which is 25.5. Now your outlier threshold becomes, outlier threshold becomes your difference of quartile, which is q3 minus q1, plus the difference multiplied by 1.5. This is your outlier threshold statistically. So basically any data point which is above this number has to be considered as an outlier. That means any number which is above this is beyond certain standard deviations, and it is not following the normal trend which all the data points are following. So any point that goes beyond it, the statistically we can conclude that that data point is an outlier. So what I'm going to do is I'm going to add one more column, and I'm going to write a formula if this number is greater than this, and I'll freeze this cell because when I drag it doesn't go and take this blank values which is beyond, which is below 42.5. And I'll say if it is greater than this, mark this number as outlier, else of course it is less than it, so mark this number as non-outlier. Here we go. When I'll hit enter, what it will do is it will sort of check each of this waiting time with 42.5, and any data point waiting time which is greater than 42.5, it will mark it as an outlier, and anything below it will be marked as non-outlier. So here it goes, as you can see. So let's do a quick check, because I introduced those numbers intentionally. So 85, you can see. And let me do one more thing. Let me just highlight text that contains specific text, outlier. Okay, control Z. Not containing, rather specific text, cell value, no blanks. All right, I think I need to figure out equal to outlier. Okay, let's leave it. I'm not able to highlight it because it is also taking into account the noun outlier, because it says it is containing something. Let me try one more time. More rules, formula, specific text, specific text, containing, beginning with. Okay, let me put it beginning with outlier, and manage rule, highlight rules, text that contains, beginning with outlier. Here we go. All right, it makes us easy to identify those outliers. So you can see 85 has been identified as an outlier, so as 100, so as 150, 100, 250, 185, 150, 300, and so on. So the formula has done the job. The formula has been able to identify all those data points which are beyond the threshold, and it has been able to mark them as an outlier with just one more formula, which is if function in Excel you must be aware of. So what do I do now? So now we have those outliers identified in the data set. What we need to do is we need to go back to this pivot table and do a refresh. And when you see refresh, when you do refresh, you will see one more field added to this field names, pivot table fields, outliers, because this is the name of the column that we have given to label all these data points. Now what you need to do is pull this field into filters. Now this average, which is 32.37, 32.35, 35.84, is an average of all the data points. But our interest is not to report all the data points. Our interest is to report the averages of all data points, excluding the outliers. So what you do is you go to the outlier filter and you take out this outlier. Here we go. So now you have the averages being reported, which is excluding the outlier 24, 24, 27. Let me increase it to two decimal points. And if I again add the outliers, the average will change to 32, 32, 35, which is not the true measure of averages because it is being distorted and skewed by these outlier data points, which usually very often comes into the data set. And this is a very easy way of, this is called interquartile range, IQR, and it's a statistical way of uh, calculating the outlier. What we need to report is averages without an outlier. Now I usually keep this very dynamic, so whenever my data changes, this threshold keeps on changing. So I'll just show you quickly. Let's say I change these data points is equal to random between, say I keep it between 20 and say 60. Okay, this is right now 42.5. So what I'll do is I'm going to change few data points and you will see the change. 42.52, it has changed to 43.125. At the same time, now based on this, it has identified other outliers. So this 57, 52, 50, 57 is all are above 43. And let's say I change it to random between say 10 and say 50. It will not introduce many new data points, but I'll just change this data set. So now you can see this has changed to 45, and it has now identified two new outliers, which is 46 and 48. So this way, your data set, whatever data set it is, the outlier threshold will keep on changing every time the new data point comes in. And your Excel or whatever system you're using will be able to identify outliers based on this threshold. And then when you take the averages, and if I refresh it one more time, you see it is the new average, which is only for the non outliers. And if I include the outliers, again it will change. So this is a very convenient way of reporting the true averages, excluding the outliers. In a hospital setting, it is very important because you want to make better decisions based on data which is true and reflecting the true picture of what is happening operationally on the ground with the patients. You do not want to make decisions based on false trends and false data points. And in a hospital setup, it is very, very easy that the false data points in terms of outliers becomes part of your data set and then sort of distort your calculations, and which we need to prevent at all cost, whether it is a waiting time, length of stay, whether it is no show rate, anything we are measuring, we are reporting in a hospital setup, we need to be very careful about outliers. So I hope this was useful for you. If yes, please do let me know. And if you want to know something else, you want me to add calculations for some other matrices in a hospital setup, I would be happy to do that. And I'm planning to create more videos of calculating different KPIs within the hospital with the help of an Excel, so as to make your life easy. And one more point before I conclude is that once you know how you're calculating certain KPIs on an Excel, then it becomes very easy to replicate the same in any system that you're using, because you know by hands, you know by yourself how have you arrived at a certain calculation data point. When you do it yourself, it makes more sense to do more sense to you. At the same time, you understand the trend better than anyone else. So, all right, thank you everyone for watching this video, and I would request you to subscribe to my channel so that you can get notified as and when the new videos are uploaded on my channel. Thank you. Have a nice day.